This video is your tutorial for the Pallant SPSS Survival Manual homework for Chapter 18. As was the case with Chapter 17, we are using two different data sets, so I will be pausing the video at least once to toggle back and forth between our two data sets. For questions 1 and 2, you'll be using the survey.save data set. For question 3, you'll be using the experim.save data set. So we'll start with question 1. And in Chapter 18, what you're learning to do is an analysis of variance. And this is where you're comparing groups when you have 3 or more groups of participants. And this can be either because you have participants who are assigned randomly to 3 or more groups, or when you have 3 or more naturally occurring groups. So in question number 1, what you're being asked to do is to, using the survey.save data set, you're going to perform a one-way between groups analysis of variance to compare levels of perceived stress across 5 different age groupings. So you've got 18 to 24, 25 to 32, 33 to 40, 41 to 49, and then 50 and over. And then I ask you to describe the findings. The instructions for the one-way analysis of variance are on pages 264 and 265 in your Pallant textbook. And following the instructions, you go to Analyze, Compare Means, and you go all the way to the bottom and select One-Way ANOVA. Now here you have a dependent list. That's where you put the variable that you want to compare the groups on, and we are comparing them in terms of levels of perceived stress, so total perceived stress. Put that in the dependence box. The factor in this case is going to be the age, but it's grouped in 5 groups. So we select age 5 groups. You put that in the factor box. One nice thing that you don't have to do in ANOVA that you do have to do with the t-tests is you don't have to define the groups. It does that for you. Why they don't fix that with the paired comparisons, I'm not sure. Probably because you could use a t-test if you wanted to single out 2 groups and ignore all the others. All right, continuing on, you click the options box and you want to select descriptives. You also want to select the homogeneity of variance test. You want to select the Brown-Forsyth and the Welch test. And you also want to select means plot, because that's going to show you in graphical form so that you can visualize the difference between the groups if they are present. For missing values, you want to make sure that the box is ticked for exclude cases, analysis by analysis. I'll be honest, I've never known what that means. Then under post hocs, you want to select the Tukey test, and then you're ready to go. So you click continue and you click OK. So when you're looking at the output, as we saw with the t-test output, you're always given the descriptive statistics first when you've clicked to ask for those. So you've got your means. You also have your breakdown in terms of the number of participants that's in each of your age groupings. The age groupings are listed over here. Then you have your means. I always eyeball these numbers and I say, you know, what looks different from what? And I immediately notice that the young group seems to be reporting higher stress than the other groups. I noticed that there's a couple of groups that are closer to 25 or 26, but there seems to be a pretty, at least eyeball-wise, a distinct difference between the really young group and the others. So the next step, and as usual in your Pallant text, you need to look at the pages where the interpretation is explained for you. So that starts on page 266 and goes on through 268. The homogeneity of variances option, where we asked it to do Levene's test for homogeneity of variance. It tests whether the variance in scores is the same for each of the three groups. And what you're wanting to look for is the significance value. And you're going to ask the question, is the number greater than 0.05? And if it is greater, then you haven't violated the assumptions of the test. And our significance value is greater than 0.05. So we are okay on our homogeneity of variance test. So then we go down to the ANOVA test. And in that case, what you see is the F value. So the things that you're going to report are the F value, the significance value, and the degrees of freedom. So when we look at the just the overall test, and basically here's what this test does, the overall F test. It says, anywhere in this group of means, is there a difference? It's not asking the question which pairs are different yet. It's just saying anywhere in this pile of means, is there a difference? And the answer is yes. So you've got your F value. The significance level is, you ask the question, is it below 0.05? It is. So what you have then is a significant group difference. Now we have to suss out where. And that's why you ask it to do post hoc test. In your text, that's listed as multiple comparisons. So if you look at this, and it's a really busy table with lots of numbers in it, but once you kind of get your head around it, what you're testing is, this is the young group, and it's going to ask, is there a mean difference between 18 to 24 and the group of people who are 25 to 32? This is the mean difference, the significance value. And again, it has to be less than 0.05, and the answer is yes, that is true. So there's a significant difference between the youngest group and the group of 25 to 32-year-olds. And there's a significant difference between the youngest group and the 50-plus group, but non-significant differences between the youngest group and the other two, the middle-age groups. Now, if you scan down your column here of significant differences, you notice that those are the only two differences that there are, is between that youngest group and the oldest group, and the youngest group and the group just a little bit older than it. The middle-age group, we don't have significant differences there. So that's where you can kind of go back up to your means and say, okay, the youngest group is significantly different from this group, and it's significantly different from this group, but not significantly different from these two. Now, how you write this up, if you go to page 269 in your text, there's a very long paragraph that you can read through as an example of exactly how to word and how to report the statistics in the gray box at the top of the page on 269. For number 2, I've asked you to, again, we're still using survey.save. I want you to run the test, and I want you to pay specific attention to the post hoc test. So I'm not asking you to just do the post hocs. I want you to, when I rewrite this, I'll reword the question. But I want you to do the same analysis you just did, but this time we're going to do self-esteem as our test variable and use the 3 grouping version of age. So we go to Analyze, Compare Means, One-Way ANOVA. We're going to remove total stress and replace it with total self-esteem. We're going to remove the 5 groups for age and replace it with the 3 groups. I'm going to check our options again, make sure all our boxes are still checked. And for post hocs, we still want to do Tukey's. And then I'm going to click OK. Now I'm going to look at the means, and I can say to myself, does there appear to be a pattern there? What is the pattern in these means? Well, the 45 plus group appears to have higher self-esteem than the middle group, 30 to 44, but really different from the youngest group, the 18 to 29s. So you have the lowest scores in the 18 to 29 group, the highest scores in the 45 plus group. Now, just like we did with the last test in question number 1, are significance values less than 0.05? They are not, so we have not violated the homogeneity of variances assumption. When we look at the overall test, which means anywhere in this group of means, is there a difference? And the answer is yes, because our significance value on our F test is lower than 0.05. Then I want to ask the question, where are the paired differences? So I take the youngest group and I look at for my significance test values, and what I can see is that the only significant difference is between the youngest group and the oldest group. And what that means is that the oldest group has significantly higher mean self-esteem than the youngest group of participants. Now you can see this visually when you graph it out. You see increasing levels of self-esteem across the 3 groups, but the only significant mean difference is between this group and this group. Now I'm going to back up for a second, since I didn't talk about with the previous test with the 5 age groupings, I didn't talk about the means plot. And remember how we found that we had significant differences between the 18 to 24 group and the group just a little bit older than them, and between the 18 to 24 group and the 50 plus group. So when we look at the means plot, there's a significant difference from here to here, and there's a significant difference from here to here. But the differences are not significant from here to here, from here to there, from there to there. It's just from the youngest to the next group, the youngest to the oldest group. Those are the only 2 significant differences in your paired comparisons. For number 3, we need to switch data sets because we want to practice doing a repeated measures ANOVA. So we're going to use the experiment.save file, and you're going to conduct a one-way repeated measures analysis of variance to compare fear of statistics scores for the 3 time periods, time 1, time 2, and time 3. You're going to then inspect the plots and describe the impact of the intervention and the follow-up 3 months later, and then give a description of the findings. So the instructions for this test are on page 275 in your textbook. And to run the test, and you can follow along with Pallant's instructions, you go to Analyze, and General Linear Models, or Model, rather, and Repeated Measures. Now, I have always found this dialog box to be super confusing. Essentially, what you're going to do is to say, I'm comparing over time. I'm looking at scores over time. So the within subject factor is essentially time. So I'm going to replace this word factor 1. In fact, you don't have to replace it, but let's just call it time, because we're measuring fear of statistics at 3 time intervals, time 1, time 2, and time 3. So we have 3 levels of that variable. And then you have to click Add, and then you can move on. So then you click Define. So the within subject variable, again, it's still time. We need to tell it where to find it in the data set. So we want to look at fear of statistics. So time 1, you put that over, goes into the 1 box. Then you need to find fear of stats time 2. And you need to find fear of stats time 3. The next step, you click on the options box. You want to get descriptive statistics. You want estimates of effect size. And then you click Continue. On EM means, you're going to open that up. You want to select your independent variable, and in this case it is time. And you want to display means for that. And you want to compare the main effects. In the confidence interval adjustment section, you want to select Bonferroni. And then you click on Continue, and then you click OK. All right, so as I usually do, here are my time periods, and what we're measuring is fear of statistics, so high scores mean more fear. So you have higher fear at the beginning, at time 1, a decrease at time 2, and a further decrease at time 3. Now, still, we need to know, is that a significant change? So in your text, you need to read on pages 277 through 279, how do I interpret this output? And there are lots of boxes here. So you need to kind of be patient, read through the description carefully so that you can follow along. Now the first section, you have, and as Pallant says on 277, you'll notice that this technique generates a lot of complex looking output. So you've got tests of sphericity, that's the Mauchly's test, and basically if you violated the assumption, you have a significance value that is our significance value is 0.00. So in this example, we have violated the assumption of sphericity. There are ways of compensating for it, but what you need to do is explore the output further. So in the descriptive statistics, you need to look at the mean, standard deviation, and n, make sure that they make sense. They make sense. They're within range, and we don't have outliers or extraordinary levels of standard deviations. Under the multivariate tests box, so this box, what we're interested in is the Wilks lambda, so that's the second one, and the associated probability value in this the significance column. And what you see is this is below 0.05. So you've got a significant Wilks lambda value. You also want to look at the partial eta squared. So the Wilks lambda, which the p-value is less than 0.05, so we can conclude that there's a significant effect for time. Now, just like with our other tests where we're doing an ANOVA, you don't know where in this group of means that difference is yet, but what it says is there is an effect for time, and it's in the predicted direction. So that's why you look at the means. If I say my intervention should reduce fearfulness about statistics, then I want to see a reduction in fear over time. And this test statistic says that, yes, we have a change over time, and by looking at the means, I see that the change is in the predicted direction. Now, for the effect size, since we have found a statistically significant difference between the scores over time, now we need to look at the partial eta squared. And for this particular test, what we have is a partial eta squared of 0.635, and the common guidelines are 0.06 is a moderate effect, and that's basically what we have. So we have a moderate effect size for the strength of the result. Then you look at the pairwise comparisons. And again, we still have a lot of really busy, complicated output to look at. But basically, you've got time 1, time 2, time 3, and you're going to make every paired comparison. So I go down to the pairwise comparisons box, and I can look at and I can see the 3 groups. They're all different from each other. So group time 1 is different from time 2 significantly. Time 1 is different from 3 significantly. Time 2 is different from 1, time 2 is different from 3, and 3 is different from 1, and 3 is different from 2, and so on. So we have a significant change over time, and it's different from each time to the next time. Now, in your text, when I ask you to write a description of the findings, there is a couple of different examples that they give you. On the bottom, in the bottom of page 278, you have in the gray box, you have a description, a sample of how to write up a one-way repeated measure ANOVA, and that's the kind of sentences that I want you to write. So, for example, one-way repeated measure ANOVA was conducted to compare scores on the fear of statistics test at time 1, time 2, and time 3. There was a significant effect for time, and then you report the Wilks lambda value and the F-test result associated with it. And you also provide the multivariate partial eta squared